Hello dear students. After learning simplification of CFG, let's now learn what is Chomsky Normal Form CNF. Now CNF stands for Chomsky Normal Form. Check that CNF is nothing but CFG. That is, it is another way of writing context-free grammar. I repeat, CNF, Chomsky Normal Form, is nothing but CFG, but it has some rules. Chomsky Normal Form has some rules that every production has following form. See, whenever in CNF you write any production, it should have either this form or this form, where the first form says that a non-terminal like x derives exactly two non-terminals. On the right hand side, you have exactly two non-terminals. You have absolutely no more symbols over here on the right hand side. You don't have any terminal. You have one non-terminal followed by another non-terminal. That's what I have explained. A non-terminal on the left derives non-terminal 1 followed by non-terminal 2. Or the another form of the production is a non-terminal derives a single terminal. Just see, on the right hand side you can have only one terminal or two non-terminals. That's what I have written. Non-terminal derives exactly one terminal. But then don't go very far. This is nothing but CFG. So if I show you this grammar, you should first instantly say that the given grammar is context-free grammar, is CFG. But note, every production has non-terminal on the left and two non-terminals on the right. So isn't this in CNF? Yes. Check this production. It has a non-terminal on the left and exactly two non-terminals on the right. This is in CNF. Check the third production. It has a non-terminal on the left and exactly one terminal on the right. This is also in CNF. One non-terminal B on the left and single terminal on the right. This is also in CNF. And finally, capital C, that is non-terminal, derives small c, that is terminal. This is also in CNF. This grammar is a context-free grammar, but this context-free grammar is in Chomsky normal form. Any such grammar which is a context-free grammar will be said to be in Chomsky normal form if it has production either of first type or second type. As another example, you see this grammar. Now, the given grammar, again, the given grammar is a context-free grammar, is CFG. Let's see the first production. A single non-terminal derives exactly two non-terminals. So this follows CNF rule, Chomsky normal form rule. The second production, here we have a single non-terminal capital A deriving a terminal followed by a non-terminal. This is not in CNF, because in CNF you can have X derives two non-terminals or X derives a single terminal. But here a terminal followed by a non-terminal is derived. So one of the productions of this grammar is not following Chomsky norm rule, but third production is following the rule. Non-terminal A is deriving a terminal. Fourth is also following the rule. Non-terminal B is deriving a terminal. But one of the productions is not following the rule. So the given grammar is not CNF. It is CFG, but it is not CNF. But this grammar is of course CFG. This is context-free grammar, and the CFG is in the form of CNF, Chomsky normal form. Now, why are we learning this? Check that this grammar is often very simple, very easy to be interpreted. That's the reason why CNF is used. As an example, let's say I am asked that given this CNF, derive a string. Just check my words. Derive a string. Let's say the string to be derived is A. Let me think. A followed by A followed by C followed by B. This is the string we are asked to derive. Now, if you try to derive this string using parse tree, then you start your derivation from S, start symbol, and S can derive A, B. We have used the first production. Now, what can A derive? A can either give us single A, observe, or A can give us AC. We will use A derives AC, correct? Now, what can A further give us? A can give us small a. Just observe we have got this small a. Okay, I'm sorry. Let's take a string. I went wayward over here. Sorry for this. This string is not A B C. This is A B C or ACB. It's ACB. This is the string. So we got A. Now what can C derive? C can derive C using this rule. And what can B derive? B can derive B using this rule. Now observe that we have got A, C, B as the result of the parse tree. So what? You might feel, okay, we have derived the string, but you observe that every node of this parse tree has two children, two child nodes, or single node, single child. So it's like a binary tree. Observe, it's a binary tree. The parse tree that you will get in the derivation of a string, when you derive a string using CNF, when you derive a string using parse tree, you will see that the parse tree will always have maximum two children and minimum one. And binary trees are very easy to handle when compared to multi-way trees. As an example, I am writing a grammar which is not in CNF. Say as an example, AA, BB, A derives AA or A and B derives, let's say B. And we are asked to derive a string, let's say A, then A, then one more A, then B, then B. Maybe this time I am correct. I want to derive this string. Now, if I draw a parse tree, S can give me A, capital A, B, B. Straight away you see that the root S is having four children. Now, this is already a terminal, but what can A give me next time? See that A can give me AA. I got two A's to start with, you watch. So this node is having two children. Now what can this A give us? A can give a single A as you observe. So I got third A in my output. This B is already a terminal and this B can finally give me B. This is a general tree. Why general? Is because sometimes a node has four children, sometimes the node has two children, sometimes the node has one child. It's many times very easy to handle a binary tree in our programming. So basically CNFs can be used rather if you want to represent the derivation in the form of binary trees. I hope you understood the rules about CNF, but don't forget CNF is a CFG with these rules on every production. Okay, thank you very much.